All right, let's dive right in. We're going to break down what the IPCC, that's the Intergovernmental Panel on Climate Change, is telling us about sea level rise. What does the science actually say? And more importantly, what does it mean for all of us? You've probably seen a ton of images just like this one, right? Melting ice, retreating glaciers. It's become a really common and pretty powerful symbol. But here's the thing. Behind these dramatic pictures, there's a whole story being told by cold, hard data. So the real question is, what is that data really telling us about the future of our oceans? Okay, so to get a handle on where we're going, we've got to look back at where we've been. And when you look at the historical data, one thing becomes crystal clear, something you just can't argue with. The rise of our seas is accelerating. Believe it or not, for most of the last 2,000 years, the global sea level was, well, it was pretty stable. Think about that. For centuries upon centuries, the change was so slow you'd never notice it in a lifetime. We're talking just a few tenths of a millimeter a year, basically a flat line. And then, everything changed. Right around the mid-19th century, that long, stable pattern just broke. The rate of sea level rise started to tick upwards, and it was a total departure from those thousands of years of stability. And this graph, it shows that shift perfectly. What you're looking at is the global sea level since the year 1700. See how it's a pretty gentle slope for the first century and a half? But then look what happens right around the late 1800s. That curve just takes off, it gets way steeper. That, right there, is the acceleration we're talking about, captured in a single line. So let's put some actual numbers to that curve to see how big a deal this is. Through most of the 20th century, the rate was humming along at about 1.5 millimeters per year. But check this out. Between 1993 and 2010, that rate more than doubled. We're talking 3.2 millimeters per year. That's a huge jump in a pretty short amount of time. So the big question is, why? Why is this happening? Well, the IPCC report points to a few key reasons, the main physical drivers behind this whole thing. Okay, it really comes down to three main culprits. First, when the ocean gets warmer, the water actually expands. Second, and this is the one we see in the pictures, we're losing a ton of ice from glaciers and those massive ice sheets in Greenland and Antarctica. And third, even changes in how we store water on land, think groundwater, for example, that plays a part too. Let's zero in on that first one for a second, because it's actually the biggest piece of the puzzle. It's called thermal expansion. And the basic idea is super simple. It's just physics. You know how when you heat something up, it expands? Well, the same thing happens to water. As the oceans absorb more heat, the water itself takes up more space. And when you're talking about the entire global ocean, well, that little bit of expansion adds up to a lot. Okay, so you might be thinking, this is all interesting, but how certain are we about this? And that's a great question. So let's talk about the confidence levels that scientists have in this data. When it comes to that thermal expansion we just talked about, the confidence level is high. And that's not just a hunch. We're talking about a conclusion built on a really solid foundation, a deep understanding of physics, tons of real-world measurements, and some very powerful computer models. And this, right here, is just incredible. This is why the confidence is so high. The black line, that's what the climate models predicted would happen with thermal expansion. And the blue line, that's what we actually measured in the real world with our instruments. I mean, just look at that. They're almost a perfect match. When your models line up with reality this well, you know you're on the right track. All right, now for the other huge piece of the puzzle, melting ice. This chart is really telling. It shows the total ice we've lost since 1992. You've got glaciers in red, Greenland in green, and Antarctica in blue. And what do all three have in common? They are all going up, up, up. That means we're consistently losing more and more ice. And all that meltwater has to go somewhere, straight into the ocean. And one thing I appreciate about the science here is how transparent it is. For example, there's medium confidence in the projections for all the world's glaciers. And that makes sense, right? It's just incredibly difficult to track every single glacier on the planet. But for the massive Greenland ice sheet, there's high confidence that its surface is melting faster and faster. We can measure that one much more easily. So we've looked at the past, we've looked at the causes. Now for the big one, what does the future hold? What are the projections for the rest of this century? Let's take a look. Now this chart looks at just thermal expansion, but it shows the different paths we could take. Each colored line represents a different future based on our emissions. They call them RCPs. All you really need to know is that the blue line at the bottom, RCP 2.6, is kind of the best case scenario if we cut emissions drastically. And the red line at the top, RCP 8.5, that's more of a worst case, business as usual, high emissions world. Okay, so when you roll everything together, the thermal expansion, the melting ice sheets, the glaciers, all of it, this is where we land. By the year 2100, even in that best case scenario, we're likely looking at a rise of somewhere between roughly 0.3 and 0.6 meters. But in the worst case scenario, that jumps to between half a meter and nearly a full meter. It just goes to show you, the choices we make really, really matter. And to really wrap your head around what those different paths mean, let's just focus on glaciers for a second. In that best case world, the projection is that we'll still lose somewhere between 15 and 55% of all the planet's glacier ice by 2100. But if we end up on that high emissions path, that number skyrockets. We're then talking about losing between 35 and a staggering 85% of all glacier volume. The difference between those two scenarios is just immense. Okay, we've looked at a lot of charts, a lot of numbers. So what's the bottom line? What is the one crucial thing you absolutely need to take away from all of this? It really all comes down to this one sentence from the report. It says it is virtually certain that the rate of sea level rise this century will be faster than it was between 1971 and 2010 under all scenarios. Now, when a scientist says virtually certain, they mean 99 to 100% sure. So what they're saying is, no matter what we do now, it's a lock. The seas will rise faster than they did in the recent past. Let me just say that again because it's so important. The crucial point here is that we are already locked in to a future where our oceans rise faster than they have for most of our lifetimes. That acceleration we saw in the data, it's baked in. The only real question left is how much faster? And really, that's what this all boils down to. The science isn't giving us a single sealed fate. It's showing us a menu of possible futures, a range of different paths. And the data makes it incredibly clear that those paths lead to very, very different places. So the final question isn't what the science says, it's which one of those paths are we, as a global community, going to be on?